ninjas. This one's called Find the Unknown Digit. This was a good challenge. I think it's fun that we're kind of getting into some more meaningful ones here. They start out by saying to give credit where credit is due. This problem was taken from the ACMIC-PC Northwest Regional Programming Contest. Thanks given to the problem writers. Here we go into it. You are helping an archaeologist decipher some runes. He knows that this ancient society used a base 10 numbering system and that they never started a number with a leading 0. He's figured out most of the digits as well as a few operators, but he needs your help to figure out the rest. The professor will give you a simple math expression of the form number, operator, number equals some answer. He has converted all of the runes he knows into digits. The only operators he knows are addition, subtraction, and multiplication, so those are the only ones that will appear. Each number will be in the range from negative, a million, to positive a million, and will consist of only the digits 0 to 9, possibly a leading hyphen or a negative symbol for negative numbers, and maybe a few question marks. If there are question marks in an expression, they represent a digit rune that the professor doesn't know. Never an operator and never a leading negative sign. All of the question marks in an expression will represent the same digit, and it won't be one of the other given digits in the expression. No number will begin with a 0 unless the number itself is 0. Therefore, 0, 0, and other numbers where there's a leading 0 like 0 and 8 would not be valid numbers. Given an expression, figure out the value of the rune represented by the question mark. If more than one digit works, give the lowest one. If no digit works well, that's bad news for the professor. It means he's got some of his runes wrong. Output -1 in that case. Complete the method to solve the expression. To find the value of the unknown rune, the method takes a string as a parameter representing the expression and will return an int value representing the unknown rune, or -1 if no such rune exists. So feel free to look over that description any more as necessary. Otherwise, you can go ahead and get started on this and then come back in when you're ready. So I think I'll start out by just sort of listing my general approach to solving this problem, our algorithm. All right, so in general, what do we want to do? I'm going to start by getting the tokens in a string form, and by that I mean the operands, the operator, and the answer value. Again, they could have question marks mixed in at certain digit positions, but that's where we'll start. We all know that. Operands, operator, answer. So once we have that, we'll go ahead. We should make a note which integers are already in use, right? Because we know the question mark value that we're seeking is not one of the ones that appears. That was part of the rules. Once we have that, we can iterate over the unused integers, right? And then we'll sort of plug those into the expression, into the question mark slots. Plug these, let's say starting from the lowest value, right? Because they wanted us to favor the lower side. They said if multiple digits worked, that we should return the lowest one. So let's starting from lowest value. And then we sort of plug those values into expression for question marks. Check if the math adds up. We'll see if the expression holds when we do that. If we can find one of those, then we know the answer. And then finally, return the first value we find that works. Otherwise, -1 if none of those values work. So that's going to be the general strategy here that I work from. Feel free to write out an algorithm statement of your own if you want to take a different approach. So I'm going to get rid of their instruction code there, and then we'll get into this. To help things out, let me bring in the system namespace, because printing out statements will be your friend here. I'll say console right line input expression. This will let us know when we hit trouble what expression we're looking at the given time. So first things first, how do we break down this expression? I'm going to grab that operator symbol first, right? That one can be a little tricky because it contains a minus symbol, which can also be a negative symbol for the second operand, right? So there could be, you could have a minus if you were subtracting a negative value. So it's a little bit nuanced and we'll have to be careful there. So to do that, we're definitely going to be using regular expressions here. So I'll say int, we'll call it the operator index, and I'll probably just make a helper method to do this and offload this work. Get operator index, pass it the expression, right? And then for this to work, we've got to implement this method. It's not made yet. So let me get us some more real estate there. Private static, and we're returning an integer representing the index in the expression string, right? And then once we know that, we can kind of use the substring method of the string class to grab the parts that we want. And we called it get operator index, passed in a string expression. Okay, good. So the key will lie in making a good pattern for the regex class. And why don't I go ahead and bring in, using system text regular expressions. You probably have that one memorized by now too. So good. We're going to use that match, if you remember that. So I'll say match equals regex match. And then we provided input in a pattern, if you remember that method. So our input is obviously the expression. Now what goes in here? And I'm going to use this @ symbol like we normally use to turn off the escape sequence. So for this, what can we have going on in our expression? We're going to start matching it from the front. So we could have a optional negative symbol. Imagine if the first value is negative, right? It could be, it could not be. So if you recall, you put the symbol that you're looking for, and then if I add a question mark, it means that this can happen 0 or 1 time, either or, and that's perfect here. Can be there, it might not be. So that's good. Then we're looking for a numeric value, right? 0 to 9, with the other catch that we can have question marks mixed in at any point. So I'm going to add question mark as a valid character that I'm looking for as well. It can match with any numeric character. That's what the 0-9 is. It's just a shorthand for, so I don't have to type out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have that, and we could have, we need at least one number, right? It wouldn't just be negative and then times. That would be gibberish. So we know it's going to have at least one number, and the plus symbol denotes one or more. So we need one or more of those. So that's good. I think we're good there. Next, we're looking for one of the operators. And so we know there are 3 choices here: add, multiply, and subtract. And if you tried this already, you may have gotten in trouble if you put the subtract in the middle, because then it thinks you're trying to say the characters between plus and multiply, and you probably got some weird behavior after that. So I just kind of jumbled up the order so it views these as symbols, specific symbols that I want to match. So we got the operator, and then I'm going to go ahead and specify that there's just one of these that I'm matching. I could go into another minus sign right for the next operand if it were a negative value. If I had plus negative 12, you know, it could, or I'm sorry, if I had minus negative 12, it could be minus minus, and I just want that first one, you know. And then I think this pattern should cover us like this. We'll certainly find out, right? So I think we're good there, semicolon. Then we know that the match object returned has a property called success if it was able to find the pattern. And so if we did get that, we'll return match. Value is what we matched, and then I'm going to say length minus 1 to get the index position of the operator. So imagine it's going to match everything. Consider one of the expressions like 5 plus 12 equals 17. So this pattern here is going to take that initial 5 and it's going to grab the plus symbol, right? But it won't grab the rest of it. It'll stop. Well, I mean, the pattern will match as long as it covers this first part. So we will get all the text, but we want to stop at we'll get the text up to here, and we want to go 1 back because the operator is 1 character, right? So that's why I did the minus 1. I did the length of the match we make for this. It will stop after the operator. We won't get second operand in the equals part. And then minus 1 to move back 1 space. So when we use substring, we grab 1 character and get it. And so there's no reason, if they have valid input, and they do, that this should blow up, but we should never get here, but you can cover yourself if you'd like. And you could say something like couldn't find operator for expression, something like that. Okay, so this is good. We're going to get an index. This will be handy, assuming it works. Solve expression op index. So at this point here, we know where the operator is, and we can grab that symbol. So we can say string, I'll call it op for operator, is going to be the expression, right, substring, and we're going to put op index, where to start, and then how many characters we want. We want 1. The operator is always 1 character. So that's how that works. And then now that we have that operator index, this is really handy for grabbing the 2 operands and the answer value. And while we're at it, we can totally get our breakpoints by adding, an equals index to grab that equals sign, right? And so this would be expression index of, if you recall that, and we'll say the equal sign. So now we also know the index of where that occurs. And with these 2 bookmark places, you know, these checkpoints, we can grab the rest of the values. So we can say string operand 1 will be equal to expression substring, start at the beginning, right, and go up to the operator index, op index. Good. We'll do something similar to get operand 2. And then for operand 2, we want to start after op index, right? It's going to come after the operator. So I'll take op index plus 1, and then it will be the space between the equals index and the op index, right? However many characters that is. You can imagine. So I would say equals index minus op index, minus 1 for counting purposes. And we'll see, I'll make a print statement so we can see this working out. But you can imagine that between the operator and the equal sign, the difference between these two values is the number of digits in that number, right? So we've got that, and finally we need the answer. So string answer will be equal to just basically everything after the equal sign, right? Expression substring equals index plus 1. And remember, if we don't specify a second parameter, it should take all of the remaining text, which is perfect here. So let's go ahead and, as a sanity check, just make sure that this is working how we expect it to. So we could say something like, I like to tab the rest of these, so we'll have the input expression from the left, and then all this stuff for the same test will kind of be indented, and that should make it easier to read. I'll say tokens. We can say operand 1, operand 2, and answer. I suppose we should put the operator in there as well, right? Operator. And then we called that one op. Add a comma. Okay, I think that'll work. So clearly it's going to return the wrong answer right now, but let's just make sure before we get too deep that this is, we're getting the values that we want. And you can take a peek as usual down at the tests here. We're going to get 1 plus 1 equals question mark first. So let's see if that's working. Tokens, operand 1 is 1, operator is plus, operand 2 is 1, and answer is question mark. Cool. Looks good. So that means this operator regex worked, so that's good. So what's our next step in the algorithm? We can go through the values that we just gathered, grab all the digits in there, and then sort of make a collection noting those, because we know they won't be an answer for the question mark value. That was part of the rules, that they wouldn't be. So I think I'll make a collection to hold those values. So I'm going to bring in system collections generic, and we'll look at a new data structure here. Private static, and we'll use something called a sorted set. And sets are nice because they don't allow duplicate values. You can imagine we're going to go over all these operands, answers, and they could have many repeated digits, and I don't want my set here cluttered with a bunch of values. I don't really care. I just want the distinct values, right? So I can do it this way, and then when I add values to it, it will automatically filter out the duplicates. So for this set, I'll call it ints used in expression. New sorted set of type integer. We can initialize it there. Okay, so that's good. And then I'll make another helper method to sort of populate that collection. So private static, I don't need to return anything because I'll just load this collection up right here. In fact, I'll even copy the name while I'm here. So we will go ahead and load that up, load ints used, something like that, right? And we're going to have to pass in our data. So for this we could say string operand 1, string op, string operand 2. I'll just do them in order. String answer. Okay, good. Now basically here I will treat all of these strings as character arrays, and then I'll use some link methods that you can probably guess, basically to grab the number values in there and skip over any operator symbols and question marks that we find, and then load up this set. The sorted set has a method called add that you can use for adding values to it, similar to a list. So feel free to consult the doc pages on sorted set for more information. So I'll say var nums use. We'll make this. This var is just kind of a generic thing where you don't have to actually type out the type. It can be nice for shorthand. So I'll use that here. I'll say operand 1, and then I'm going to use the where, that filter method as I call it. We know that we're dealing with characters here, right? And so what do I want? I want to filter out characters not equal to question mark, right? Because I'm looking for the digits. Yeah, and there's another way. The char class we've seen in the past has something I think called isNumber. So you could do it that way too if you'd like. And then keeping with this, I'll say and char is not equal to a dash, right? We could have a negative value in there. So that's good. Then I'll I gotta remember these are characters at this point, so I will transform them into numeric values. And I can take each character, use this one that we've used recently called get numeric value, ch, and this will sort of turn that into an integer, take it from the character printed form to an actual integer, which we want to add to our list, our sorted set. Good. So now I kind of have to do the same thing with the other data. So we'll go, let's call this one op2 nums used. Make sure we do it on operand 2, and we still don't want question marks or dashes. And then we have to do one for the answer nums used. Again, filtering out the question marks and dashes. And then I'm going to sort of pile all these enumerable collections together into one giant collection, and then I'll just take all of the values in that, and so I can make one for loop and just kind of do it in one shot there. So we know that these have a method called concat, where we can sort of append collections together. Op2 nums used, and then in this case I'll just chain it to get the other one as well. Answer nums used. And then I'm not sure why I used op here. Op will never have numeric content. We don't even want to process it, so don't worry about that. And then finally we've got this one. We can call it all nums used. And then we can use that for each int n in all nums used. And what do we call the ints used in expression or something like that? What was the name of the... Oh, there it is. Ints used in expression dot add, just like list, and we could say n, and it will take care of filtering out the duplicates, give us unique values. So that's good there. We just got to make sure we invoke this. load ints used with operand 1, operand 2, and answer. So that will get that collection ready for us. Good deal. So then the next step will be, in general, to go make a loop of the numbers from 0 through 9. We'll step through all those starting at 0 because they told us to favor lower values, and we'll use that continue statement we saw previously where we can skip values. If it's in our sorted set, we'll say don't even bother, we know that's not the answer, it can't be the answer, so we'll skip over it and not use it. So I will make another helper method for that. We'll use their missing digit, and I'll say call solve. For this, I've got to give it operand 1. Definitely needs the operator now. Operand 2 and answer. Okay, so now we've offloaded the work. The magic's got to happen in this. Solve. Private static int solve. String operand 1. String op, string operand 2, string answer. Okay, so here's where the magic's going to happen. For solve then, I mentioned that we're kind of going to be going over all of the integers starting at the bottom. Nothing new here. We know how to do a for loop from 0 to 10. I is less than 10, increment I. Alright, so in here, what do we want to do? Well, first things first, right off the bat, if the index is contained in our collection, we know, hey, it can't be the answer, so don't bother. Ints used in expression, and like list, sorted set has contains, and we could say I. And if it has that value, we know, hey, don't even bother, don't waste your time processing, just go to the next one, find a valid one. Good deal. So then we have the issue still to address of where these operand and answer values are going to have question marks mixed in. And so we're going to have to make something that can replace the question marks with a test value. So for that, you know, and we'll want to get back something in integer form. We've been dealing with a string to date, but we're going to want operand 1 val, I'll call it that. And so we're going to want something like replace questions with num, right? And then we could give it the string operand 1 and then a replacement value that we'd want, which will be an integer I. So then we'll offload that work to a new method as well. Keep things small and focused. Okay, and we know it has to return an integer. That's what we're looking for here. So because once we get all the integers, we can actually run the math. We can say, hey, if the operator is plus, take this integer, add it to this integer, and it should be equal to the integer answer, right? So first things first, we gotta do that. String, let's call it value text, because this will be reused for operand and 1 and 2 and the answer. And then we want a replacement value for the question mark, right? And so for this, we can use the strings replace method that we've used before. String replace, right? And so what we want to replace is you give the string that you want replaced, which is question mark in this case, and then we want the value to replace it with, which is this replacement. We could have passed it in as a string, but you know, as the parameter, or you can convert it to a string here. I'll do it this way since I've already made the signature here. And so then string nums only. So at this point there are no more question marks, right? And it's handy. I can start with 0, give it 0. All the question marks, bam, turn into 0. Then I test that out. It doesn't add up, so I go, okay, try it again with the value 1. Replace all of them with 1s. Boom, boom, boom. 1s are in. Try running the math again. Oh, nope, it still doesn't equal. And then we kind of repeat that process. That's what we're doing here. And so to get it back into number form, we're going to go int parse, right? Nothing new there. We've been using that for a while now. Nums only. I didn't even need to create the temporary variables, so if you want to do this all in one line, go for it. And so yeah, we're going to get operator 1 this way, or operand 1, excuse me, this way. And so we can kind of do something similar for operand 2. Copy paste, pass it operand 2, we'll give it a unique name. So we've got operand 2. And then we also need an answer. Answer val equals replace with num, answer, and I as well. Remember, it gets the question mark's the same value. It can't be different values. So we're always passing the same value I in. So good, we have integers to run with. And now we need something, we basically need to check if the math works out, right? So we could have something like is valid expression, and if you took operand 1 val, if you took the operator operand 2 val and answer val, this could actually run the math for us and give us the verdict if it's true or false. If it comes out true, we know we have our answer, right? And we started at the bottom, so we don't have to worry. We can just short circuit out of here. It takes the lowest working value, so just return I at this point. And then we know that if we process all of the values and none of them hit, then the archaeologist made a mistake, and we're going to give them back a -1 to denote that. So we got to implement this. Private static bool is valid expression. And then we've got to match operand 1 string op int operand 2 int answer. And so we'll sort of use a switch statement here for each of the 3 operators and run the actual math to make that determination. So we'll switch on the operator, and then remember we have our various cases. It's a string, so in the case of plus we can say return operand 1 plus operand 2 equals answer. If that's true, then yeah, the expression's valid. Case subtraction, colon. Same kind of deal, but we're not adding anymore, we're subtracting. And then again, same, our third operator, and this time it's multiplication. And then we could add something just for error checking purposes. We could say throw a new exception unrecognized operator. It just if somehow some garbage gets in there, that's what we'll do. So yeah, that's nice. That'll actually run the math for us. Should be good here. There's one finer point that we should address in the main method, and that's handling the case of 0. 0 is a special case, right? They told us that zeros could not be leading numbers. So you could imagine if a number has a question mark at the beginning, then the number can't be 0. So we can again short circuit in that case and just avoid processing. We know 0 can't be the answer. It breaks the rules, right? So let's add something else that can possibly short circuit. And this would only apply when I is equal to 0, right? And so what can we do? Let's make another helper for this. Offload the work. 0 is valid guess. And for this, we'll pass the values involved, operand, operand 2, and answer. And then we'll leave it up to that method to determine if 0 is valid. From this point, you know, we just kind of want to do the math, have someone else figure it out. Just let us know if we need to skip. So notice I added the exclamation mark for negation. If it's 0 is not a valid guess and our current index is 0, let's not even bother with it. So now we've got to make this private static bool, right? And string operand 1, string operand 2, string answer. Those are the values that we're dealing with that could have question marks in them. And so basically we're going to be doing the same kind of process for each one of them. We just need to check, number 1, if the value has a question mark in it, and number 2, if it does, make sure it's not the first character in there. So for this, we can do something like, if operand 1, we'll use index of again, right, to check if there even is a question mark. And if there is, that'll be some value greater than 0 and less than the length of the string, right? So if it's greater than -1, that's saying that a question mark was found in the value. So, because if that condition's not met, then we're fine. There's no, like if you just had an operand with all numbers in it, who cares? Just, we don't have to worry about it. Not a problem at all. It's only potentially a problem if the question mark is found. So I'll make a, this 0 is valid guess. We'll sort of do this same process for each one of our parameters, right? And then we can kind of generalize the next part of checking the first digit of each. So I could say 0 is valid for value operand 1. If it's not, or if there's no question marks in here, this condition will be true, or we'll get to this line that I'm about to type now, right? If there are no question marks involved. So we'll say 0 is valid guess. You can simply say return false at this point. I suppose I could have written these all out and then copied them, but written one of it all the way out. So we'll do something like this. Answer and operand 2. So then we offload it again, right? Do a little bit of work at each stage, offload to somebody else to keep everything small. Static bool. And then we want this more general form, string value text. And this can handle all 3 cases where we don't really care if something's an operand or an answer. You know, it doesn't really matter for the purposes of what we're trying to achieve. So we can say if value text length is equal to 1, simply return true. Okay, that's a trivial case. So I want to deal with the potential case where the value could have a negative symbol, right? So we have two cases. If it's negative, it has that dash character first. If not, then it's not. But this affects what the first digit is, right? If we're trying to grab the first digit, we need to know if a negative sign is involved. So to do that, I can make a flag. It says is negative equals value text. Access the first character if that's equal to the character minus, and that means we have a negative value, right? And so how to sort of get around that and deal with this uniformly, I will say like an absolute value would be is negative. We can say value text substring 1, where we're taking everything except the first character, right? We're skipping, or you can think of it as chopping off that negative sign. Otherwise, just take the input as it came in. There was no negative sign to worry about. So once we have this, we can grab the first character unconditionally and check if it's a question mark. So we can say return absolute value character index 0, which is the first character, is not equal to a question mark, right? If it's not equal to a question mark, then 0 is valid for the value. Otherwise, you can't have 0 as the first character. You could have, if it's just one question mark, right, you can have a 0, that's fine. They said that if it represents the number 0, there's one question mark, that's fine. So we're good there. But after this, we know we have more than one character. So that should take care of this. And then 0 is valid guess was sort of tasked with doing this process for each of the 3 values that we need to check. So we're good there. That simplified this part up here. And I think that made our solve method okay now. We can go test, and as usual, the proof will be in the pudding. Let's condense this back down, see what kind of stuff we're getting. We may need to add some print statements if things are going haywire here. That was a lot of typing for me not to have made a typing error. So we got 1 on line 72. 72, yeah, semicolons help, right? You got to terminate your statements. You got to make a complete statement. Otherwise, it's like you're talking and you just don't quite stop and you leave it hanging, and the computer doesn't like that. 98, 99, and 100. Let's go down to those lines. 98, 99, 100. What did I botch here? Syntax error, comma expected. Where? Ooh, I see a problem. How about an and in here? This definitely doesn't make sense. We're listing 2 different conditions there. 2 different clauses. So let's see if that cleared it up. Line 53, not all code paths return a value. 53. Zero is valid. Oh, sure. So like if we got through here and there was nothing that sort of invalidated 0, why don't we just say return true at the end? Line 100, string does not contain a definition. Oh, so I didn't bring in system link, did I? Using system link. Remember, link has those extension methods that allow us to do these extra behaviors with strings. Okay, so we had some failed tests. tokens. It looks like it's parsing. Okay, 1 plus 1. Answer. Let's put in some more print statements to see what is being returned in here. Int missing digit. So I can say console right line. I'll tab it out again. We'll say returning or missing digit. Should help make some sense. I probably should have tabbed. Okay, that's just running over on lines. I don't think I can neaten that up any. I want to see what kind of answers we're getting here. Missing digit equals 2. So yeah, that one looked right. 5. Missing digit 6. That looks right. Missing digit is 0, negative 50 times negative 1 equals 50. Yeah, that seems right. Well, why don't I just scroll down? That's where they show you where the problem is. Test failed. Answer for expression. Question mark times question mark. They expected 5, so I guess 55 by 55 is 3025. And so, why didn't we get that? Input expression is this. Tokens. Operand 1 is double question mark, which is good. Operator is times. Operand 2 is double question mark, and answer is 3025. That all seems reasonable. Missing digit is negative 1, which is not reasonable. So I might need more printing here. Let's go ahead and see for each n in ints used in expression, that sorted set that we made. I can say console right line. How should we name this? Setting, let's tab it to setting used value and make sure it's grabbing the right values. Oh, I see what I did. So that was helpful. Okay, so look at the output there. It's saying that for this equation here, right, the values we loaded up into the sorted set are 1, 2, 3, 4, 5, and 9, but only 302 appear. So what happened is that I made this collection out here, but I should be clearing this every time. So you may have wanted to create this as a local parameter. You could have done it here and then passed it into solve, but since I didn't do that, this value is being persisted, and each time they call a test, it's not getting cleared, so it's having the set values from previous examples, which is really bad. It's saying that numbers are used. It's not even considering the value 5 because it's saying it's a used digit and ineligible. So that's bad. We're going to have to clear that for each run. So once we solve the problem, I'll just add a line that says ints used in expression. We'll clear it out, and then it should start fresh every time. Let's try that. There we go, there's the green. Okay, so that's the first wave. Let's see what they're going to hit us with in the attempt. Okay, we failed again. What do we have now? Input expression. Negative, that, tokens, operand. 1 looks right, 5, 6. Operator is a minus. Operand 2 is a negative 9216, which looks right. Answer is negative question mark 47157. The used values then are, we'll check them off from left to right, 65373 9216. Missing digit 4. 4 should not have even been eligible, right? Because it appears in here. Missing digit 4. They were expecting 8. Okay. So let me check what could have went wrong here. Solve expression. True. Operand 1 index of. Seems reasonable. Question mark. Okay. Replace load ints used. Something seems to be wrong with the load. Oh. Yeah. I see it. So you might want to cover all of the input. And that was sort of our clue with the error too, right? Was that it was in the answer value. We knew that 4 should have been printed out here, setting used value, and that was coming in the answer, so it was like the answer wasn't getting processed properly. And so I think I changed it. Change that to answer. That looks better. Answer nums used, opt. Okay, that looks good. Let's try that. Gotta be careful with that copy paste. That's some insidious bugs. There's that green we love. So bam, we hit them all. I'll go ahead and remove the print statements, my little algorithm notes there, and then I'll submit it off and grab those points. We can get rid of them. And then I could say, and say just return it, right? Return solve. Actually, no, I can't do that. Not the way I did it, where I call this clear first, so I'll leave that. Okay, looks good. Yeah, all right, they'll make me run it again and then I'll submit it. There we go, all green. So yeah, that's one way of doing it. I would like to see whatever solutions you all came up with. Bam, up to 400 points, love it. So, wow, that's a cool. That's a nice way. Yeah, so go ahead and look through these too and see what you can learn from that. Otherwise, yeah, hit me up with questions, or I will see you in the next challenge. Thanks for watching.